Hello and welcome. Today I am reading the article about the Solar Parker Probe speed and its mission, so let's begin. The Parker Solar Probe is a NASA space probe on a mission to study the Sun's outer atmosphere, the corona. It was launched on August 12, 2018, and is named after Eugene Parker, the astrophysicist who first predicted the solar wind. It is the fastest spacecraft ever built, traveling at speeds of up to 430,000 miles per hour, 700,000 kilometers per hour. This is fast enough to travel from Earth to the Moon in just 4 hours. The Parker Solar Probe's mission is to study the Sun's corona up close. The corona is the outermost layer of the Sun's atmosphere, and it is a region of extreme heat and activity. The probe is designed to answer some of the most fundamental questions about the Sun, such as: the Parker Solar Probe is equipped with 4 instrument suites to study the Sun's corona. Fields. Measures electric and magnetic fields. Sweep. Measures the solar wind plasma. WISPR. Takes images of the solar wind. ISIS. Measures the solar wind ions. The Parker Solar Probe uses a combination of gravity assists and solar thermal propulsion to achieve its high speeds. Gravity assists involve using the gravity of a planet or other celestial body to increase or decrease the spacecraft's speed. Solar thermal propulsion uses the heat of the Sun to heat a propellant gas, which is then expanded through a nozzle to produce thrust. The Parker Solar Probe will make 24 gravity assists from Venus over the course of its mission. These gravity assists will help the probe to slow down and spiral closer to the Sun. The probe will also use solar thermal propulsion to accelerate during certain phases of its orbit. What challenges does the Parker Solar Probe face? The Parker Solar Probe faces several challenges on its mission to the Sun. The Sun's corona is extremely hot, with temperatures reaching up to 2 million degrees Fahrenheit, 1.1 million degrees Celsius. The probe is protected by a heat shield that can withstand temperatures of up to 2,500 degrees Fahrenheit, 1,377 degrees Celsius. The probe is also exposed to high levels of radiation from the Sun. The radiation can damage the probe's electronics and instruments. The probe is designed to be radiation hardened, but it is still important to protect it from excessive radiation exposure. What has the Parker Solar Probe accomplished so far? The Parker Solar Probe has already made several important discoveries during its mission. The probe has found that the Sun's corona is much hotter and denser than previously thought. The probe has also observed new phenomena in the corona, such as switchbacks in the magnetic field. The Parker Solar Probe is still in the early stages of its mission. The probe will continue to make close approaches to the Sun over the next few years. During these close approaches, the probe will collect even more data about the Sun's corona. The data collected by the probe will help scientists to better understand the Sun and its role in space weather. The future of the Parker Solar Probe. The Parker Solar Probe is a groundbreaking mission that is pushing the boundaries of space exploration. The probe is providing scientists with new insights into the Sun's corona. The data collected by the probe will help to improve our understanding of space weather and the Sun's impact on Earth. The Parker Solar Probe is a reminder of the human spirit of exploration. We are constantly striving to learn more about the universe around us. The Parker Solar Probe is a testament to our ingenuity and our ability to achieve great things. I look forward to seeing the amazing discoveries that the Parker Solar Probe will make in the years to come. The Parker Solar Probe would not melt because of its advanced heat shield. The heat shield is made of a carbon composite material that is extremely strong and heat-resistant. It is also coated with a special white paint that reflects sunlight away from the spacecraft. The heat shield is designed to withstand temperatures of up to 2,500 degrees Fahrenheit, 1,371 degrees Celsius. This is much hotter than the temperature of the Sun's surface, which is about 9,941 degrees Fahrenheit, 5,505 degrees Celsius. The heat shield works by blocking thermal radiation from the Sun. Thermal radiation is a type of radiation that is emitted by hot objects. The heat shield blocks this radiation by reflecting it away from the spacecraft. The Parker Solar Probe is a very smart spacecraft. It is equipped with a number of advanced systems that allow it to operate autonomously and to collect data from the Sun's atmosphere. For example, the Parker Solar Probe has a system that allows it to automatically adjust its orientation so that it is always pointed towards the Sun. This system is necessary because the Parker Solar Probe is constantly moving and changing direction. The Parker Solar Probe also has a system that allows it to collect data from its instruments and to transmit that data back to Earth. Overall, I would say that the Parker Solar Probe is a very smart spacecraft, but it is not intelligent in the same way that a human is intelligent. The Parker Solar Probe's cooling system is essential for keeping the spacecraft's instruments and electronics from overheating. The system uses water as a coolant, which circulates through channels in the spacecraft's solar panels and other components. The water absorbs heat from the components and then flows to 4 radiators, which are located in the shadow of the spacecraft's heat shield. The radiators dissipate the heat into space. Let's talk about Eugene Newman Parker. June 10, 1927 to March 15, 2022, was an American solar and plasma physicist. He is best known for predicting the existence of the solar wind, a continuous stream of charged particles flowing from the Sun into space. Parker's theory was initially met with skepticism, but it was later confirmed by spacecraft observations. Parker was born in Houghton, Michigan, and received his bachelor's degree in physics from Michigan State University in 1948. He then went on to earn his Ph.D. in physics from the California Institute of Technology in 1951. After completing his Ph.D., Parker taught at the University of Utah and the University of Chicago. He retired from the University of Chicago in 1995, but he continued to be active in research until his death in 2022. I hope you liked the article. Thanks for watching. Please watch, subscribe and comments. Stay connected for more.